For centuries, the Great Pyramids of Egypt have stood as silent sentinels on the edge of the desert. They are monuments of incredible scale and precision, leaving us all to wonder, how did they do it? We've long imagined armies of workers dragging massive stones up ramps, a testament to human will and brute force. But what if there was more to the story? What if the ancient Egyptians possessed a level of technological sophistication we've underestimated? The logistics of moving millions of stones, some weighing several tons, has always been the central puzzle. Traditional ramp theories, while plausible, leave nagging questions, like the sheer size and lack of evidence for such ramps. Each theory comes with its own set of logistical problems, and a distinct lack of definitive archaeological evidence. The pyramids are not just tombs, they are a challenge thrown down across the millennia. They dare us to understand the minds of their builders, to appreciate their ingenuity, and to look beyond the obvious. Every time we think we have a handle on how this ancient civilization operated, a new discovery turns our assumptions upside down. The allure of solving this age-old riddle is irresistible, a quest for knowledge that connects us to our ancient ancestors. And now, a radical new idea is about to move from the fringe into the heart of mainstream Egyptology, forever changing our view of the ancient world. The story of this breakthrough begins at Saqqara, the ancient burial ground of the Old Kingdom. While Giza often steals the spotlight, Saqqara is where pyramid building began. Here, a French archaeological team led by Xavier Landreau has been quietly working for years, re-examining the complex around Djoser's Step Pyramid. Using ground-penetrating radar and seismic sensors, they mapped a labyrinth of tunnels and chambers beneath the pyramid. They noticed anomalies, structures and channels that didn't fit any known purpose. These weren't tombs or storage rooms, but something that suggested a large-scale, coordinated system. The team focused on deep shafts and excavated basins near the pyramid's base, features whose true purpose had remained a mystery. Landreau's data connected them in a way no one had considered, a network of channels forming an elaborate plumbing system. The most startling find was a massive buried structure resembling a dam, positioned to control water flow. The evidence pointed to the ancient Egyptians managing large volumes of water at the construction site. This wasn't just for drinking or irrigation, the scale was immense, designed for a powerful purpose. The secret to building the pyramids might not be ramps, but a forgotten science of hydro-powered engineering. At the heart of Landreau's discovery is a concept that sounds almost like science fiction: a hydraulic lift. The team's analysis suggests the Egyptians engineered a system to use water pressure to raise heavy stone blocks. A deep, vertical shaft lined with water-resistant plaster was designed to hold water. At the bottom, scans revealed a chamber with a sealed channel leading toward the pyramid. The hypothesis: a watertight wooden caisson would be placed in the shaft, loaded with a stone block. Water from nearby basins would fill the shaft, and as the water rose, it would lift the caisson and the stone upward. This water-powered elevator could precisely control the ascent by regulating water flow. Once at the right height, the stone could be slid onto the pyramid, and the water drained for the next cycle. Evidence includes guide rails, traces of wood and rope, and sediment layers consistent with such a device. The builders of Djoser's pyramid were not just masons, they were brilliant hydraulic engineers. A hydraulic lift system needs a massive, reliable water supply. Landreau's team discovered a huge man-made dam at a higher elevation than the pyramid complex. This dam, about 15 meters high and nearly 100 meters long, created a large reservoir. It was designed to capture the seasonal floodwaters of the Nile, which once reached much closer to Saqqara. Canals diverted floodwater into the reservoir, creating a giant battery of potential energy. From the main reservoir, a series of interconnected basins and channels stepped down toward the pyramid. These basins acted as secondary reservoirs and pressure regulators, allowing precise control of water flow. The cascade of basins ensured a steady, manageable flow, preventing surges that could damage the lift. This infrastructure shows the builders were terraforming the landscape to suit their engineering needs. They understood gravity, water pressure, and potential energy. Hidden beneath the sand, this system represents a level of planning and hydraulic expertise never before attributed to this era. It was a complete, self-contained industrial complex powered by water. The system didn't end with the basins. The Egyptians needed an underground plumbing network to move water to and from the hydraulic lift. Landreau's team mapped a web of straight plastered tunnels connecting all key components. Some channels angled downwards to feed water into the lift shaft, others led away for drainage. The main delivery channel was large and robust, built for high-volume water flow. Alongside it, a smaller channel likely served as a control mechanism, allowing fine adjustments to water levels via stone gates. After a stone was lifted, a large drainage shaft led water into a deeper, porous layer beneath the plateau, acting as a natural soakaway. This allowed the system to reset rapidly, key to the construction timeline. The underground network was the circulatory system of the project, connecting the dam, lift, controls, and drainage. For centuries, these tunnels were dismissed as unfinished tombs or ritual passages. Now, they're revealed as conduits of an ancient industrial machine. The Egyptians mastered not just what they built above ground, but the world they engineered beneath it. Their ingenuity ran deeper than anyone imagined. This discovery forces us to see the ancient Egyptians as master engineers and scientists. The Step Pyramid's construction was a complex scientific and industrial feat, not just an act of faith or royal power. The builders understood physics, hydrology, and project management at a level impressive even today. Before laying a single stone, they designed and built the entire water management infrastructure. They worked with stone, wood, rope, and waterproof plaster, showing multidisciplinary expertise. Specialized guilds of engineers and technicians likely passed down this knowledge, refining techniques over generations. This challenges the simplistic view of Egyptian technology as limited to basic tools. The hydraulic lift is a true machine, multiplying force and harnessing nature's laws. The Egyptians used their brains as much as their brawn, achieving monumental goals with surprising sophistication. Their legacy is not just in what they built, but in how ingeniously they built it. For over a century, the ramp theory has dominated our understanding of pyramid construction. The discovery of a hydraulic system at Saqqara doesn't just add a detail, it upends the old picture. If the Step Pyramid was built with hydraulic lifts, it changes everything about the construction process. Resources once thought spent on ramps may have gone into water management instead. A hydraulic system is more efficient, less labor-intensive, and safer than hauling stones up ramps. It explains the speed and precision of pyramid construction, allowing a continuous assembly line process. Ramps may have been used for ground-level movement, but the heavy lifting was likely done by water power. The history books must now include a new chapter on hydraulic engineering, and we must ask, could similar systems be hidden at other pyramid sites waiting to be discovered? The Saqqara revelation opens a thrilling new frontier for Egyptology. Every major pyramid site must now be re-examined for signs of hydraulic engineering. Buried dams, hidden basins, plastered shafts. Technologies like ground-penetrating radar will be crucial in this search. The focus turns to Giza. Could the Great Pyramid have used an advanced version of Saqqara's technology? Anomalies like the voids detected by Muon scans may be clues to hidden chambers or mechanisms. Ancient texts and inscriptions may hold overlooked references to these techniques. Linguists and historians will revisit primary sources, searching for hidden clues. This discovery will fuel a new wave of exploration and attract a new generation of scientists. The search for the secrets of the pharaohs is far from over, it's just beginning again. The Step Pyramid of Djoser marks a new beginning in our understanding of ancient Egypt. The discovery of this hydraulic system is a paradigm shift, revealing the Egyptians as rational, innovative problem solvers. They met unprecedented engineering challenges with elegant, effective solutions. This knowledge enhances the wonder of the pyramids, replacing the image of mindless labor with skilled engineers operating complex machines. It deepens our appreciation for their intellectual achievements and their ability to harness the Nile's power. The pyramids are monuments of human intellect as much as human labor. This is a moment of pure excitement for anyone fascinated by the mysteries of the past. History is a living story, constantly evolving with each new discovery. Many secrets remain buried beneath Egypt's sands, waiting to be told. The breakthrough at Saqqara reminds us that the next great discovery could be just around the corner. The quest to understand their world continues, and it's more thrilling than ever.